Okay, so the title of today's talk is No AGI Without Neurosymbolic AI. And I know most of you, I think a lot of you have heard me say these things before, but I'll try to give the view, maybe not even from 30,000 feet, but from 50,000 feet in the context of LLMs. So how do you get to AGI? Well, first you have to ask, what do you mean by AGI? I used to get feedback saying, but nobody's talking about AGI when you criticize these neural networks. Now everybody's talking about AGI. So I placed or offered Elon Musk a $100,000 bet because he said AGI would be here by 2029. So I defined it for him. I said that I took AI to be a shorthand for any intelligence that is flexible in general, with resourcefulness and reliability compared to or beyond human intelligence. And I checked with Shane Legg and Ben Gertzel and really came up with the term. They were all good with it. So that we can take that as a provisional working definition of AGI. And then if you want later, you can read on my Substack that some of the specifics I said you should be able to do, like scene understanding, video understanding, etc. Okay. So one hypothesis, which is so popular, people made t-shirts of it, is called scale is all you need. Probably most of you have seen these graphs that came from OpenAI, and they portrayed scaling as if it was a law of the universe, like gravity. And for a while, I've been saying, no, it's not a law of the universe. It's more like Moore's law, which could hold for a little while. It doesn't guarantee that it will go perpetually. Back in 2021, in August, Stanford wrote a paper that's been very influential, calling large language models foundation models. It was like 200 pages long. It was the longest academic paper I think I'd seen in a long time. It also had like 80 authors. That set off a trend too. We've seen 600-page things. Ernie Davis and I immediately wrote a reply. We said, has AI found a new foundation? What you would want in a foundation is something reliable. That's the whole point of the foundation of a house or a skyscraper or whatever. And we argued that maybe they weren't so reliable. That was back in 2021. Then I wrote a paper that made great, huge, enormous number of people hate me. And that paper was called Deep Learning is Hitting a Wall. You weren't allowed to say that then. And basically it was an argument against scaling. I made points about things like hallucinations and so forth. And I made so many people really, really mad. Like Sam Altman, I can't see it on this screen, said, give me the confidence of the mediocre deep learning skeptic. And Greg Altman made a fool of himself by making deep learning hitting a wall, which foretold the kind of errors that we still see. I'll come back to this later. And Yasha Bach had the funniest one with a robot stepping over the walls. Jan LeCun, this is the, Wittgenstein, there's the earlier and later Wittgenstein. There's the earlier LeCun and the later LeCun. The earlier LeCun, up until ChatGPT came out, said not only is AI not hitting a wall, cars with AI power driving assistants aren't hitting walls or anything else either. That was, of course, before all the data about Cruise came out, et cetera. But back in those days, people were mad that I said that scaling wasn't going to get us all the way there. And there were articles like Nando De Freitas at DeepMind saying his opinion, it's all about scale. The game is over. This actually led to my Substack. It's May 14th, 2022. And I get so mad at this claim by Nando's that I wrote an essay about it. It's formed a Substack and written on 150 cents or something like that. But this is actually the one that launched it. So by now, the scaling hypothesis has been funded orders of magnitude more than any other hypothesis in AI history. Many orders, 5 orders of magnitude, maybe more, 4, I'm not quite sure. It's made immense progress. We have ChatGPT, we have GPT-4, Gemini Pro, Sora, Codex, and so forth. But I would say it has failed to yield AGI. Anybody who tells you otherwise is kidding you. It's failed to replace radiologists. It's failed to solve autonomous driving. We saw Cruise almost go out of business recently. It's failed to solve common sense. It's failed to provide reliable and trustworthy basis for AI. It's failed to solve long-standing bias issues and so forth. So there's no doubt that there's been progress, but on some of the things that at least made me want to go into AI in the first place, I think we haven't actually solved them, that we need to be honest about that. And the interesting thing is, I'm no longer the only person, well, I wasn't ever the only person, but I'm no longer getting flack from the same set of people, and it's actually becoming trendy to say this. And trendy among some kind of surprising people. Sam Altman said it recently. After calling me a mediocre deep learning critic, he's now kind of saying most of the same stuff I'm seeing, which is saying, which is also a theme, of course, with Jan LeCun. There was a great poll I ran on Twitter. The winner for what explained Jan LeCun's recent tweets was that he was ChatGPT trained on @Gary Marcus tweets. So he's rather changed his view considerably. I wasn't here to talk the other night, but I'm guessing it's similar. Bill Gates has suggested that there's a plateau. And even Demis said a couple of days ago, if you look as recently as July, he was hedging his bet saying, maybe scale will solve the problems, maybe not. Now he's pretty much saying scale is only going to get you so far. So I think that people who actually have access to these giant models they don't always share with us are seeing that in fact scaling is not everything. Oh, this arrow key is not going to work. And so I have in the back t-shirts as well. Mine say scale is all you need with a little circle crossed out. I don't really have that. That's just a joke. But I think it's time. And I've been running with this quote for a really long time. You probably all heard me say it before, but it's still true. Deep learning is a better ladder, but a better ladder doesn't necessarily get you to the moon. And we've been using the same one for 12 years. Okay, so if not scale, then what? I've also used this before and I stand by it, which is we have to think, if we were thinking about human cognition, natural intelligence, which is not the only way to do things, but is the best model that we have, there's actually lots of things that go into it. So there's perception, which deep learning is pretty good at. There's language we could argue about. There's reasoning. I would say anybody who thinks that these things are reasoning or wrong, we could talk about that in discussion. Analogy, there's an argument they do a little bit of it. Planning, they're terrible. I think Rao has great work on that. Common sense, I think there's still margin. So we have part of what we need, but I wrote another paper that made Jan LeCun really mad called Deep Learning Critical Appraisal, and I don't think he ever read this paragraph. But in it, I said, despite all of the problems I've sketched, I don't think we need to abandon deep learning. Rather, we need to reconceptualize it, not as a universal solvent, but simply as one tool and one headache. I said that in 2018, 100% stand by it. So that brings me to Neurosymbolic AI. I think Neurosymbolic AI is part of the solution. I'm thrilled to see sessions like these and all the kinds of things Alex mentioned. It's not the whole solution. I'm actually going to talk about why. But the first thing I'm going to do today is talk about what Neurosymbolic AI means to me. I think there are many different definitions of it. I think, we as a field in Neurosymbolic AI can't even agree on whether or not we want a hyphen in the word Neurosymbolic AI. So, there's no consensus here. But here's mine. So in this book, The Algebraic Mind, which I think, contributed to the existence of the field, I laid out what I meant by symbol manipulation. Of course, I didn't invent the term symbol manipulation at all. It goes back to people like Newell and Simon, voter volition, and you could argue there's a much longer history. But I emphasize three things. The first is I said that the human mind, the book was mostly about cognitive science rather than AI, but it was a lot of it was about neural networks and the limits. I said that the mind represents abstract relationships between variables. It represents recursively structured representations, and then it has a distinction between individuals and kinds. And I basically said these three things are non-negotiable. I made an argument that they might be innate in the human mind, and I said we weren't going to get out of cognition without these three things. This is really, for me, the core of the symbol manipulating hypothesis. And the core of the neurosymbolic for me is that we take something from the neural network tradition and these three things. Like, what is neurosymbolic? That would be the minimum definition for me. So this would be the symbolic piece, and neural part might be, for example, large language. And I argued about extrapolation out of domain generalization. I gave these examples like the identity function. Do I have a laser pointer? I guess I do. So I said, look, if you train on the identity function for odd numbers, for even numbers, you won't generalize to odd numbers with multi-layer perceptrons that were popular then. Of course, we didn't have large language models, but this is still a problem to foreshadow a lot of what I'm going to say. So I distinguish then between generalizing within a space of training examples and generalizing outside. And I said, with these neural networks that we have, or that I could imagine at that point, that this would be a problem. This, of course, then in part helps fund lots of other work. Like I think Artur is here, and maybe Luis is in the room somewhere too. Sorry. Ostensibly, everything has changed since the Algebraic Mind. That book was written in 2001. We had neural networks then that didn't do anything that was practically useful. We didn't have GPU clusters. We didn't have an internet full of data. Nobody was spending billions of dollars developing them. Most people had never heard of neural networks. Okay. But the reality, I would say, is that we still have exactly the same problems that I was concerned with in 2001. The deep issues that I was worried about have not changed. I did not anticipate Sora. Like when I was writing the book, I didn't say we could do Sora or we couldn't. I didn't really think about that. If I had, I probably would have said it's going to have some problems with physics. There is some work in the book that touches a little bit about that. There are lots of things I didn't anticipate. I didn't anticipate that computer programmers would find enormous value in large language models to code. Asterisks around that, the quality of the code is actually going down, so I'm not sure that the value they perceive is actually there. But anyway, there are lots of things I didn't imagine. But the things that I worried about are still problems. And I'm going to try to go through that. So here's an example where someone systematically looked at within and outside of domain generalization. It's still a problem. They were doing this, I think, in this case, with GPT-Day, where you can actually look at the training data and compare on arithmetic inputs and outputs. And they found there was a pretty big similarity effect, like the kinds of things that I was worried about in the Algebraic Mind. There was a pretty clear problem of generalizing outside of domain. That remains a problem. A lot of the book was about things like operations over variables. One of the ones I actually talked about was greater than. Here's an example where ChatGPT falls on its face. You ask, what's more, a kilogram of bricks or 2 kilograms of feathers? There's now a whole genre of examples like this on Twitter. You often, not always, get cases like this where it says in air, 2 kilograms of bricks would weigh slightly less than 1 kilogram. Or sorry, of feathers would weigh slightly less than 1 kilogram of brick. This is obviously a failure to understand the greater than operation, or in the language that I used in the Algebraic Mind, it's a failure of free generalization. You're still seeing this stuff. Here's another example. You can say, wow, these new things, they can draw all kinds of pictures, you give them text. Well, get them to draw a Venn diagram, for example. They are not freely generalizing the concept of Venn diagrams. And if you look closely, they're not even freely, identity was in the slide I just showed you before. They don't even understand identity of text. So my prompt here was to do code understanding and memorization, and it messes up, prediction, memorization, and understanding or something like that. It can't even copy the words for all x, f of x equals x. So the kinds of generalizations that chapter 3 of the Algebraic Mind are about are failing both at the micro level for identity of the words, and then they really don't understand what a Venn diagram is. I could have infinite examples. My friend Phil Lieben likes to send me different kinds of wacky applications. Here's one where he said, do an infograph of the United States and illustrate for each city what it's famous for. And there's all kinds of problems, like with one-to-one mapping. So it doesn't know that, which was, again, part of the Algebraic Mind. It doesn't know that the Empire State Building or the Statue of Liberty can only be in one place. And it invents new cities like New Angeles, where you need an umbrella, or they sell a lot of umbrellas up there and something like that. Pretty wacky stuff. Keep hitting the arrow because I can't inhibit. We probably all saw these crazy pictures. These are actually a failure to apply some simple constraints. Can't even represent the constraints you want. So Google just really, really kind of fell on its face with the so-called woke. I mean, you take that term seriously or not, but these crazy examples like a rabbi, it's actually offensive. One of the, at least one of those examples is a really offensive version of the rabbi, in my view. It's certainly not capturing, what I think the output should be. And even factual things were wrong. So like the crew of Apollo 11, I'm sorry, it was all white males. I wish it was differently. You should all watch For All Mankind, which is a wonderful alternate universe in which there was more diversity by the time of Apollo 11. But this didn't say give me fiction. It said, just give me the facts, and it just made up. This is actually a failure to generalize constraints that represent things like history, to be able to reason over them, and so forth. One of my other books, Rebooting AI with Ernie Davis, a lot of it was about time and so forth, and how important it is to represent common sense over time is a clear failure of that. And just to remind you, I got really pissed off at all the white males that got mad at these pictures, because where they've been forever when we had a lot of pictures like this, and a lot of people rightly point out there is a lot of bias in these systems, and we still do. So I just made this one the other day. I said an ethnically diverse rock band on stage with 7 musicians And not only will you note that there's like 14 or 13 musicians, but they're also all white males, and it really doesn't understand ethnic diversity. So like this is actually a continuing problem in all directions. Nobody solved it. It's actually very unfair that people are picking on Google. Google was trying to solve a problem that nobody else solved. It just solved it poorly because the techniques that we have are not very good. Okay, compositionality, that was the second substantive chapter of the Algebraic Mind. Talked about structured representation. That hasn't been solved either. This was with DALL-E, DALL-E 2, a couple of days after it came out. A red basketball with flowers on it in front of a blue one with similar pattern. You get the flowers, you get the blue ones. You don't really get the notion of similarity, and the whole, just doesn't really work. So that was a year ago, and what I always get is, yeah, but wait till next year. Wait. All right, so now we're in 2024. We still have problems. Well, here's 2023, I think. I said these systems can't get the difference between an astronaut riding a horse and a horse riding an astronaut. And I wrote a whole article about it, and I took other people's silly examples, and there are rotten excuses. I wrote all about it in Substack. And what was wrong with all of the excuses is really a problem with language understanding, and not like it's learned that horses don't ride astronauts or whatever. The problem persists. So I did this a couple of weeks ago. I made it slightly more complicated. I said a horse riding an astronaut that is sitting in a bowl of cherries. I added the bowl of cherries because one of the things we found is that the people who make large language models pay attention to public examples and fix them. So I added bowl of cherries because that wouldn't be in the public example. And whatever patch they had to solve it promptly broke. That's compositionality. The other thing that I talked about in the Algebraic Mind was type token distinction, tracking individuals. And I gave the example of my late Aunt Esther, who was still alive then, and I said, suppose that she won the lottery. If you look at the mechanics of how these neural networks, the ones they had then, are working, it would generalize to other women working at Harvard or living in Massachusetts or whatever, that there was not a distinct representation of Aunt Esther independent of the categories that she belonged to. Well, here's a really wacky example in which ChatGPT thinks that I own a pet chicken named Henrietta. There may be some human being or white male or scientist or somebody who owns a pet chicken Henrietta, but I don't. And so it doesn't have a good database representation of me. Didn't go to Wikipedia to fact check it because Wikipedia doesn't say that. Or any other source. It just made it up. So the hallucinations that we're seeing constantly, and I hope many people saw Pascal's talk last night. I gave her a hard time about a couple of points, but the talk was actually excellent. She showed a whole lot of different ways in which these make errors. This one is actually an interesting story. I gave this at a talk, and somebody sent me this picture the next day. There is a Gary who illustrated a book called Henrietta Gets a Nest. So why do I own a pet chicken Henrietta? Probably because in this sort of statistical flotsam and jetsam that makes all of this stuff work, there was a Gary in the neighborhood of the word Henrietta. This is not a proper type token representation. I could go on with examples like this forever, but I think I have only one more on the hallucination point, which is Marco was sitting at lunch with me, and he wrote my next talk for me. I have to give 2 talks this morning, which kind of sucks. And so he said, here, let me help you out. I'll have ChatGPT write your talk for you. And I'll just zoom in on one detail. He says, the ChatGPT, well, first of all, it says, presenter your name. So it tells other people how to write Gary Marcus talks on education, which is hilarious. But slide 3 is supposed to be discussion of how LLMs can be tailored to address educational needs, inspired by Marcus's advocacy for robust generalizable AI systems. Well, this part is probably true. Marcus is probably going to advocate for this stuff. But is Marcus really going to say you should tailor LLMs to educational needs? No, probably he's going to tell you that they suck and you should be careful. And so like it's combined like some stuff that's me and some that isn't really me. So that's another type token problem. And I just want to kind of flag how crazy people get and the fact that these systems aren't actually working very well. Somebody fed in a Mr. Beast video, which I admit I didn't see, and out into Gemini 1.5, and they were so excited about it that it came up with this summary that they posted this. Holy shit, the Gemini 1.5 Pro wasn't overhyping it. This is very, very real. OpenAI has to catch up really soon. And then other people looked at the summary, and there was, again, confabulation, all failure on kind of type token and good world models and stuff like that. It made up, 7 things in 6 paragraphs. So like none of this is solved. It's not solved with bigger and bigger models. And it's worth pointing out that Gemini is probably like $1 billion just to do the training. That's my best guesstimate, Gemini Pro. So like more money went into this test than went into the rest of AI research for like the previous 20 years or something like that. This is crazy. All right, so we still desperately need neurosymbolic AI. We're still facing the same problems. I meant to delete this slide. That's what happens when you write in haste, but basically that's correct. We're still facing the same problems of compositionality, type token, etc. All right. So I think we absolutely need to do the things that we are gathered here today to build neurosymbolic AI that has a proper type token representation, that has a proper way of representing structured representations, compositionality, and so forth, and has ways of representing abstract relationships that hold for all instances of a class. So greater than should work for bricks, and it should work for feathers, and for small numbers and large numbers, like an operator in a microprocessor, and not like this craziness we have now, where it's entirely dependent on the idiosyncrasies of how close are you to your training data, given all of this context that you fed in at this moment. Like, it's just not the right way to get to AGI. But it is not going to be enough to come up with some magical innovation in neurosymbolic AI. We need those innovations, maybe not magical, but practical. But I think there's a huge space of neurosymbolic integrations. We could talk a little if there's any time left, but that's not enough. And I want to remind people in this room that there is a larger context. Part of that larger context is about knowledge. I hope a lot of people came to the session in memory of Doug yesterday. I mean, a lot of what Doug Leonard was trying to do was to think about how we represent knowledge. There are some ways in which large language models are an advance on this, but there are other ways I'll talk about in a second, which they're not. But my point is, even if you had the sort of master algorithm that was perfect in all ways, I don't think it would work unless you had really good knowledge representation. I don't think we can forget about that. I think people don't talk about it as much, or they just assume LLMs will solve the problem. Here's an old slide that I had in like 2020 or something. It was actually based on GPT-2. I put that in red and changed one thing on the slide. But what I said is, like, things like if you break a bottle that contains liquid, some of the liquid will probably escape the bottle. And then I showed how GPT-2 failed it. And everybody will say, yeah, but GPT-4 is, so much better, and it is. But there's also like, I guess I move things around. I'll go ahead if I can. Can I hit play here? Yeah, play the video. Like, now it's 2024. It's billions of dollars of research later. And that glass just went in the air and liquid spilled out of it, right? So we haven't solved these problems at all. Then I'll go backwards. So I always think, when I think about knowledge, partly about knowledge writ large, in the sense that Doug Leonard talked about it. But I also love this quote from Liz. I don't know if she must have given some version the other night. I wasn't here. But this is from 1994. I've loved it ever since I saw it. And she said, if children are innately endowed with the abilities to perceive objects, persons, sets, and places, then essentially you can bootstrap into the world. If you don't have that starting point, then you can't. I don't think LLMs really have it. And she's always emphasized a few things, which probably she did the other night, which include object permanence, spatiotemporal continuity, solidity. We just saw a violation of solidity when the liquid comes through the glass and things like that, that basically infants understand. And some of you will know my own background was in language acquisition and cognitive development. I worked on that for decades before returning to AI for the second time in my life. And this stuff is just terrible. Can we press play? You're going to see a basketball go through a rim. It's a violation of solidity, another violation. On the second time, it goes through the rim. And then there's an explosion. I'm not even going to worry about that. I don't know if you've seen, this is a video from Sora. There's, and gravity is another one of hers. Watch how this chair violates gravity. And then watch what happens to this guy. Total violation of object permanence. The guy just disappeared, right? So we haven't solved any of this. We need to have solutions on it. We need to have solution to Doug Leonard's problem of general knowledge of the world writ large, but also of these kind of core principles that Spelke was talking about. Oops. Already done that. And we need to have ways of reasoning over complex cognitive models that we develop in the moment. So aside from general knowledge, we need to, for example, understand what happens in a scene in literature. Somebody walks in the room, somebody else walks in the room, somebody drinks a magic potion, what's going to happen? They might even be fictional, right? Romeo and Juliet depends on a magic potion that was, not available in those times. Probably isn't quite, well, there's something sort of like that now, I suppose. And you need to be able to reason over these complex states of affairs. So every time you watch a movie, especially a science fiction movie, or a fantasy movie, there are going to be like new physical principles you need to reason over, and you need to build cognitive models of what is happening in that moment. You know, which characters are here, what are their motivations, and so forth. We don't really have a good way of doing that right now. Large language models don't build interrogable is the word I like to use, although it's hard to say, models that you could then reason over. We still need to find a way of building those models, of figuring out what needs to be represented and so forth. So neurosymbolic AI is a prelude, I think, to having the rich knowledge representations we need. It is a prelude to having the rich cognitive models that we need. And so, you know, it is in part the reasoning that we need all of that, I think, to get to AGI. A lot of the arguments that I presented today are in the Algebraic Mind, also in the book that I wrote with Ernie Davis, Rebooting AI, and an archive that came out 4 years ago today, like a week before the pandemic happened. I wish more people had read it. I'm actually going to write soon a kind of 4-year retrospective of all that I just gave here. So to summarize, how am I doing on time? Do we have any? Perfect. Okay, so I have 3 last slides if I can afford it then. Summary 1, scaling alone is not all you need. I wrote this slide a couple of years ago, and it's still true. I didn't change a word. Current deep learning still struggles with reasoning and factuality, even given vast amounts of data and enormous models. I should say even vaster amounts of data. Hasn't changed. Classical AI isn't the answer either. Like, I'm not expecting that pure symbolic AI is going to solve all this. We don't know how to generate knowledge at fast enough clip and so forth. There are lots of problems. We have to combine online learning with abstraction. Neurosymbolic approaches, I think, offer our best hope here. There shouldn't be 50 people in this room. There should be 5,000. Like, if we had 1/10 of the resources for neurosymbolic AI as we do right now for large language models, it would completely change the world. But advances in neurosymbolic AI alone won't be enough, because intelligence is multifaceted, and we shouldn't expect any one-size-fits-all solution here, which is why, going back to your 3-year problem that I was teasing you about, like, we're just not going to solve all this in the next few years. There are many facets of things that need to be worked on. We also need large-scale knowledge, including some innate nucleus geared around time, space, and causality. Pretty much probably, like I would imagine Liz argued for the other day, basics like agents, sets, and places, and stuff like that. We need rich cognitive models. We also need major advances in engineering methodology. We do not, as a field, all of us put together, have any way to robustly engineer complex cognitive systems. We just don't. And like, people are playing around with tools like RAG that are, or I guess you say it out loud as RAG, that are just like Band-Aids on top of Band-Aids on top of Band-Aids. There is no systematic way that we know to engineer something like a driverless car. We just like patch things and play whack-a-mole. So there's also like room for some fundamental engineering in there. Okay, so looking for a quick win is distracting us from the hard work that we actually need to do. And just one more slide, recap things in a different way. These are 7 suggestions that Marcus and Davis made in our reply to the foundation model from Stanford. And see if I can get the animation. Where's that going? So we had 7 things. I don't know if I need the animation that we said would be absolutely essential. I think they all are. There's a little redundancy in one place. And that we haven't made that much progress since 2021. This was the fall of 21. So we said we need rich cognitive models to keep track of a dynamically changing world. I would say we still don't have that. If you can, make a video where somebody just disappears, you don't have a rich cognitive model of who's there. Like, if you're rendering it from a physics engine, that person doesn't just disappear. Extensive real world knowledge. That's the only one I think we made progress on. And I think Dave Ferrucci makes some nice arguments within our tradition about how LLMs have helped that. So you can use an LLM to get an approximate thing. What language do people speak in Warsaw and stuff like that? LLMs will usually give you a correct answer on that. So I would say we have made progress there. Representations of relationships between entities, not so much. Compositionality, clearly not. We're still struggling with that. I gave you examples. Common sense knowledge. Look at these crazy Sora videos. Like, we have not solved that. Reasoning, we still, these systems, they'll give you something that looks like reasoning. They'll be correct like 75% of the time. But that's not what reasoning is if you go back to how it's construed in like a logic class, which is like, for all X such that X belongs in this category, I will do that. There's no universally quantified anything. in the reasoning of getting on these systems, and human values. I gave an example then of a medical advice chatbot shouldn't recommend suicide. And since there's a medical, a chatbot that was used essentially as a psychiatric partner did in fact essentially recommend that somebody commit suicide. We don't know how to make basic ethical principles. We're still struggling with bias and so forth. So I still think this is the right prescription. And I would say that, except for number 2, that we still have a long way to go. And you tell me how much time I have for questions, but I'm happy to take them.
Thank you.
Thank you very much.
I think we have time for like 1 or 2 short questions. So you'll have to come here.
I wasn't asking this, but I changed my mind. One thing that I find very important in neurosymbolic models is that we search and we try to build systems that are more reliable. And we've seen like many people have advocated that there is a crisis in the US and Western engineering, right? It's a wider context question. And if we keep building patches, as you mentioned, and this is a kind of question that perhaps you haven't heard before, where are we going in terms of the kind of technology that we're developing in the Western world, in terms of safety, reliability, and so on. So there is a need for neurosymbolic systems, in my take, towards this thing. So can you develop on that, please?
Yeah, so I mean, there are technologies we do know how to develop mostly, like airplanes, which are not perfect. But we do a really good job. Commercial flight is really spectacularly safe because we have figured out multiple levels of policy and regulation and how to test certain things in simulation and what we need to do in the real world. We don't have anything like that for large language models. I'm not sure large language models can be engineered well because they're not debuggable, they're not interpretable. And so basically the only solution we have, I took out the XKCD cartoon, but you probably all seen it, the one where somebody says, this is your model, it's a pile of linear algebra. What happens if it doesn't work? You stir it. And that's basically, there's actually 2 techniques. One is the stirring and the other is the gather more data and make the pile bigger. And it just doesn't really work that well. And so like in the last 10 days, OpenAI went down for reasons that have not really been adequately explained for 6 hours. It just completely started spewing garbage. We had the bias debacle with the Google thing that is actually going to have long-term negative consequences, probably for Google, maybe for the field, I don't know. We still don't know how to engineer this stuff at all. And then you have these techniques like RAG that don't really work. They work a little bit. They help with the problem, but they really are Band-Aid like things. They're not solutions to anything. There's a lot of deferred technical debt. It's even worse because I think the code that's being written with these things itself has a lot of technical debt and is adding to the engineering problems, maybe not for the AI itself, but things that are being written with this stuff. I think it's a disaster. I think like in 3 or 4 years, people are going to be like, whoa. But it's going to take a little while for people to realize how bad the code that is being written is and how much technical debt there is. There's a great paper, by the way, I don't know if everybody's here has read it, everybody has, called something like technical debt is or machine learning is the high interest credit card of technical debt or something like that. I came pretty close by Scully, D. Scully, who is related to the Scully who used to run Apple, by the way. Fantastic paper. It's 10 years old and stakes or whatever have changed a little bit, but basically what that paper said is true, which is you don't know with these kinds of techniques what you're doing and how they're going to generalize. It can work. I think this is an example I borrowed from Peter Norvig. It could work on Tuesday and not on Thursday, or it works, but it doesn't work on Thanksgiving. And a lot of what happens is these things are tested empirically in the wild. So this is what happened with the crazy Google thing, right? So they probably tested and realized that it made more diverse pictures, which in general is a good thing, right? They were trying to do something that is noble that we should all support, right? You don't want your rock band to have 13 white guys every time. Being is not quite every time, but they were quite right to be trying to do it. They probably tested to see if it worked, but nobody thought, hey, we should test this on historical examples. And then somebody, in the outside world, once they released it to the outside world, had that idea, and then it was ridiculous and it spread and everybody realized how big a problem was, but they didn't find that in advance. Nobody really knows how to do complete testing in advance. So every deployment here is basically a beta test, right? Because nobody knows the surface area. It's not like a calculator and you can be like, okay, we're going to check multiplication, we're going to check log, we're going to try to check the order of operations. Okay, we're good. Like you can't do that with this kind of system, which proposes to do everything, right? Chatbots are supposed to literally do anything that you ask. And so the surface area is immense, and this like notion you're going to test it all before you ship it is hopeless. So like, I don't have an answer here, but it's a big mess.
So let's thank you. Do you have a question?
One more,
make it
I'll try to
very
give a
short.
quicker answer.
Yeah,
Quicker question.
very short.
So isn't an AGI something testable, or are we going to realize we'll have an AGI from a good theory? Because I know that there are some different opinion on this. Like I was curious.
I mean, I think first of all, there's probably many different instantiations of AGI, just like there are many humans that approach intelligence in different ways. So there's not one. The second is testing whether you have an AGI is actually really hard. You know, the field has spectacularly failed at benchmarking intelligence, right? Literally every benchmark of intelligence has not really been a benchmark of intelligence. Like they've been reliable tests, but they've never been valid tests. So I don't even know how you test it. The only good news I have on that question is like, I still think we have a lot of time to figure out like those kinds of questions. We're not actually that close. And probably I should stop there.
All right, thank you.
Thanks.
Thank you so much. We have some